Hello everyone. In this tutorial, we are going to provide a solution to this interesting probability question. And the question reads, in a bag, there are 10 counters. 4 of the counters are red and the rest of the counters are blue. So we have only 2 colors, red and blue. Musa and John are going to play a game. Musa will remove 2 counters at random and will not replace them. If both counters are the same color, Musa will win the game, definitely according to the question. But if the counters are of different colors, it will be John's turn to play. John will remove 1 counter at random from the 8 counters still in the bag. If the counter is red, John will win the game. But if the counter is blue, the result will be a draw. What is the probability that the result will be a draw? All right, let us bring out the data. According to the question, we have 10 counters, 4 are red. So we have 4 red and the rest are blue, which means that 6 of the counters are blue, right? 4 blue counters. Altogether, we have 10 counters. All right. According to this question, Musa will be the first player. He's going to draw 2 counters at random. If they are of the same color, he wins the game. But we don't want that situation because we are talking about draw. And the draw is only possible if Musa draws 2 different colors and Mr. John draw what? A blue color. You see that? 1 blue color from the rest. So let's start with Mr. Musa. The condition we want, or should I write the formula? We would like the probability to be a combination of the probability of Musa picking different colors, and John picking what? A blue ball. Oh, blue counter, right? So this is the formula we are going to apply. So what is the probability that Musa pick different colors? All right, let's assume that in the first draw, he picked a red counter. So the probability that Musa pick different colors, let me just make it like this. Musa pick different colors. This is equal to 4 out of the total 10. That is first draw. And which is multiplication. The other color, which is from 6 out of 9, because there is no replacement. He has picked the first ball from red and the second ball, why am I saying ball? Counter from the blue. So the first draw will be 4 out of 10. But since the total number has reduced to 9, the second one will be 6 out of 9. Or the first draw should be from the blue, which is 6 out of 10. And second draw will be 4 out of 9. So this is the probability that Musa will pick different colors. Let's reduce it to the simplest form. 4 over 10 is the same thing as 2 over 5. 6 over 9 is the same thing as 2 over 3. Plus 6 over 10 is the same thing as 3 over 5. Times, we have 4 over 9 here, but we can still reduce it because 3 can divide itself 1 time and it can divide this 3 times. So this is going to be 4 divided by 15 plus another 4 divided by 15. Together we have 8 divided by 15. Now we are done with this. Now we want a situation whereby John will pick a blue counter, because that is the only condition that will warrant a draw game. So probability that John picks a blue, remember he's only picking one ball. We expect each ball to reduce, right? This one is going to reduce to 3 and this one is going to reduce to 5. So it is going to be 5 out of the total, which is 8, and simple as that. Therefore, the total probability that we are looking for will be equal to what? Probability that Musa picks different colors, which is 8 over 15, and probability that John picks a blue counter, which is 5 divided by 8. So you can see that the 8s will cancel, this and this will cancel. We only have 5 divided by 15, and 5 divided by 15 to the simplest form is 1 divided by 3. And this is said to be the answer to this problem.